This is CPM Precalculus, Chapter 3, number 43. So here we're asked to solve each of the following equations for x. So we're trying to solve for x, but first we want to express each side to have the same base. All right. Give exact answers using fractions, not decimals. So that means do not plug into our calculator. Like 1/4 equals to 0.25, but we don't want 0.25. We want the 1/4. All right. So let's look at part A. Part A, we have 8 to the power of x plus 3 is equal to 32. So how do we get 8 to some power? So this is base 8, and 32 is base 32, and we have the exponent of 1. So how do we get these bases to equal each other? Well, what are the factors of 8? We have 2 and 4, right? Well, I could rewrite 8 as 2 to the power of 3, right? 2 times 2 times 3 is 8. And so I could rewrite the left side as 2 to the power of 3, to the power of x plus 3. And I could rewrite that as 2 to the power of 3 times x plus 3, like this, right? Because this is just multiply these two. All right. How can I represent 32? Well, similarly, I know that if I multiply 2 to 8, I get 16, and then one more time I get 32, right? So if I multiply 2 to itself 5 times, I get 32. So I can write this side as 2 to the 1 power, or I can just write it as 2 to the 5th power, right? There I went ahead and got the same base on each side. So then I can go ahead and set the exponents equal to each other. That means 3 times x plus 3 is equal to 5, and I'm just solving for x, right? So first I want to distribute the 3. I get 3x plus 9 is equal to 5. Subtract 9 from both sides. Negative 4 here, 3x here. Divide both sides by 3. And I keep x to equal negative 4 over 3. I should not put it in my calculator and put 1.3333333. Do not want this because we want the exact answers, right? As fractions, not decimals. So here we have x is negative 4/3. All right, let's go ahead and do part B. So again, we want the bases to be the same. So far I have 27 and I have 1 over 9. Okay, well 27 and 9 makes me think of 3's because 3 cubed is 27. So I could rewrite this side as 3 cubed 2 to the x, which is the same as 3 to the 3 times 2x power, or 3 to the 6x power, right? I could go ahead and write that. 1 over 9 is the same as 1 over 3 squared, right? Because 3 squared is 9 to the x minus 1 power. And I could bring this to the numerator by making it 3 to the power of negative 2, again to the x minus 1 power. And then I can go ahead and multiply negative 2 to x minus 1 and have a common base of 3 on both sides. Once we set up and have base 3 on both sides, we know the exponents, 6x here and negative 2 times x minus 1 here, are equal to each other. Now I just want to solve for x. So let me distribute the negative 2, add 2x to both sides. I get 8x is equal to 2, right? Divide both sides by 8. And x is equal to 2 over 8. Well, I can go ahead and simplify 2 over 8. 2 divides by 2 one time. 8 divides by 2 4 times. So x is 1 over 4th. Again, do not write it as 0.25 because it says give exact answers using fractions. And that's a fraction here. And that ends for us CPM Precalculus, Chapter 3, number 43.